guess I'll start then. So thank you all for coming today. Today I'm going to be talking about property-based testing in Elixir. Maybe first a show of hands. Who has written unit tests in the past before for the day job? Okay, yeah, it's good that it's quite a lot of people. I think a few years ago it would be a lot less. Maybe also the question, is there anybody that has used property-based tests in production yet? No? Okay, that's good. Then we can learn something new today. First, a little bit about myself. My name is Luc Tielen. I'm a software engineer at Kabisa. I focus mainly on the back-end side of web applications. Right now I'm working on a project that's written in Elixir. I also want to give a quick shout out to the company I'm working for, which is Kabisa. I want to thank them for giving me the time to prepare this presentation and give it to all of you today. It's a really fun company, so yeah, it's a company also located nearby here in Weerten and Eindhoven, also in Amsterdam. And we specialize mostly in web technologies. Anyway, let's get on with the talk because it's a big topic and we're going to need our time, I think. First I will do a quick summary of the way we do unit tests, and then with the focus on Elixir. After that I will talk about property-based testing. I will go over each of the key concepts and give examples along the way so that it's clear what each part of it does. And at the end there will be some time for questions. So yeah, unit tests, they're great. So I think I can keep it pretty short because most people already use them, which is super nice. But as our developers, as our projects become larger and more complex, we as developers need a way to stay confident in the software we write, that the behavior we have stays the same, and that it stays correct. For this, unit tests are great, so we can write some examples and it will give, and then we check if the result is as expected. But there's one minor thing that's not that nice, and that's that we have to think out the examples manually. So on the right I have some example code, and I put some minor highlighting there so you can follow more easily when I'm explaining, because there will be quite a bit of code today. So in Elixir, the tests are written in a separate directory, in the test directory, and then in different files. Each file will contain a module. In this case, it's simple test. And then we can start writing our tests. So Elixir is really flexible, so it uses macros underneath the hood to allow custom syntax. So here we have the test macro and the assert macro. And it allows for very readable and clean notation of our tests. Also, it provides us ways if the unit test would fail, then it would give us a pre-printed output saying, I expect this, but on the other side I received this. So it's a really nice framework, and we can use it in combination with the NextBuild tool. We just run mix test, and it will run all the tests in the current project. So what is property-based testing then? So well, previously with the unit tests we were all working with examples, so it's more of an example-based testing style. But now we are moving to properties, and it might be a little bit of a confusing term, but a property in this framework is something that is always true. So there will be more examples later on what it exactly means, so it's okay if it's a little vague right now. The origin is from Haskell. It's actually from this paper, the title here on the right, written by Koen Klaassen and John Yu. They give the reasoning behind it and a lot of use cases. It's really a recommended read if you have some spare time. And also what I want to say, what we are going to do is not exhaustive testing, so we don't go over each and every iteration or each and every possible input, but we try to select a smart subset of all the possible values in order to guarantee that our program works as intended. But that will become more clear in the next slide. Yeah. So quick check or property-based testing, it's available in a lot of languages. Today we're going to talk about it in Elixir, but if you use another language at your day job, it's worth looking for on GitHub if there is an implementation for that language. Today we are going to be talking about the Stream Data library. It's a recent library developed by one of the core Elixir team members. And the nice thing about it is that you can write it side by side with your unit tests. So how do you start using the library? The top piece of code that's located inside your mix.exs file. That's basically your project file for your Elixir project. So we just say that we want to include the Stream Data library, and we only want to include it for the test environment. Then there's one extra thing we have to add to our test module. So here we say that we use XUnit properties. And what this does is it gives us a few extra macros so that we can write our property-based tests in a way that is very similar to our unit tests. So we get two new macros here, so property and check all. Property is basically the same as the test macro before. It just gives us a place where we can drop a block of code in which we can write our assertions. And the check all macro, that's basically the macro that makes the entire engine do its work. After the check all macro, we have a set of clauses, and each of the clauses will have a generator. That's something that will generate input data. We will go over them more in detail in a few slides. And after that, you have the block of code where we do the actual assertion. And yeah, the testing, because the nice integration with XUnit, the standard unit testing framework, we can just run the same command, and it will. The only change here is now it says I'm running X amount of properties also. And that's it. So it's really nice and easy to get started with. But before we go deep into the code, maybe first take a step back and look at it from a high-level point of view. So each and every system out there in production can be modeled as a kind of data-driven application. So there goes some data in, then there is a system that does something with the data, and there comes some data out. Here in the schematic, I call this SUD, the system under test, which is what we will be testing in the properties. And then we will apply something to the inputs and something will come out. It's a really simplistic point of view, but it's really powerful. And I tend to write more and more programs also in that style because it's so easy to test. So let's take our unit test from before. So if we take the plus function I showed earlier in the first unit test, let's take that as the smallest system that we can test just for getting behind the way of reasoning. So let's say, for example, we give the inputs 2 and 3, and then we expect the output to be equal to 5. It's really straightforward. But the bad thing about this, like I said before, we have to think about each situation or each case step by step, and also we have to check manually with each output. So it's a lot of work. Property-based testing generalizes this. So instead of concrete values, now we think in terms of variables. So we have A and B on the input and C on the output. So we lose some information about the data. We can check, is it exactly equal to this? But we get the power that we can now reason at a higher level. We can think about the relations between the outputs and the inputs of a system. And this is what makes property-based testing so powerful. If you can describe your system in this kind of way, then you can keep on generating values for your system and keep on checking, is it always correct? Yeah. So then we go to the generators, and they are basically the input part of the drawing I just showed you. So most of the time when we write tests, we write some values and some simple cases, but the more difficult ones, often we leave them away because it's too much work or it takes too much time. For example, values like not a number or weird Unicode characters when you're testing something that uses strings. So this library takes care of that all for you. So you just say I want a string, and it will create complete garbage, and it will put it in the system. It will check, does it work as we expect, and it will keep on doing that over and over. What's also nice is it starts really simple. So for numbers, for example, it could start with 0, 1, and then gradually over time, after each iteration, it becomes more and more complex. So in the case something does fail, we don't get extremely complicated use cases. Yeah, as you will see in the next slide, generators are made of functions, and functions are composable. So if we have a nested data structure, we can keep on composing the generators together, which makes it really easy to generate complex pieces of data. And yeah, the framework will use generators to create the random data many times per property. So another code example. So here we have a module for something that does something with the time of the day. So the structure contains the hours, the minutes, and the seconds. So how would we create a generator for that? Yeah, we could do it in a separate module, and then because we require the use xunit properties again, we can now use an extra macro, the genAll macro, and this allows us to create a custom generator. After genAll, we have the actual generators. So for the hours, we want the value between 0 and 23, and for the minutes and the seconds, we want the value between 0 and 59. And once after these three clauses, you have these three values, and then you can combine here and store them inside the Elixir structure. And then we have created a new generator. So it's also really easy to create composite structures. So I compiled my code and I run it in the shell. So the top line here is the function that I just defined, and you see you get some kind of weird structure out of it, but you don't know what's inside because it's just logic in its essence. But we can use the great Elixir standard library because the generator is enumerable. We can just say take out the first 5 values, and then we get the list as I showed here with completely random timestamps. So this is the way you can easily write generators and test are they generating the correct data. Once you have generators, and let's say you write a property and it fails, but it's a really complex property. It would be nice if you could reduce it to a simpler failing situation. And can we do that? And we can. The process is called shrinking. So in the example on the right, I had a property where I assert that a is less than 100, and the generator, as I show there, is a is an integer between 50 and 150. So it will obviously fail at some point. In this case, it failed after 2 successful runs. But it failed with exactly 100. So how did it know that? The chance that it picked exactly 100 is really small. So how did it reduce it to that case? Well, we'll go over it step by step. So take, for example, it generates 125, and it sees that it fails. What will it do then? It will try and reduce the number, and for numbers, reducing can mean going towards 0. Either by subtraction or dividing by 2 or something along those lines. As long as the next number is smaller than the previous number, then we go towards a simpler failing situation. So the framework does it. It reduces and it goes back all the way to 99 and it sees, oh, 99 works. And then it determines that 100 is the closest failing value and it will report it back to the end user. This is a really simple case, so pretty much it will give you 100 every time, but if you have composite data structures, it might give you a slightly different result each time. But the nice thing about generating tests is you can just keep on saying mixed test, it will keep running it, and you can keep on running it until you have a really simple situation that you can start debugging. Yeah, then some real world examples. So let's say we have a bank account and we want to do a transaction from one account to the other. So at the top we have a simple module named account where we define a struct that only contains an amount value. And then we have the actual bank module that contains the logic for a transaction. So here first we check, do we have enough money to do the transaction? So if the amount from the person that wants to give money is bigger than the amount you want to give, then we do the transaction. The syntax there, it's the Elixir way of updating a map or a struct. But the important thing here is that we return the new values because everything is immutable. And also because it makes it easier to test the outputs in our property when we are writing our tests. If we don't have enough money, we just return an error saying we don't have enough money. Then we come to the actual test. I chopped this one into pieces because it's quite a lot of code. So here we are writing a generator for bank accounts. So like before we use a gen_all macro, and then we say generate me a random number between a certain range. We don't know beforehand, we can specify that later. So we give that via a parameter. And we return the account struct so that we can use it later. Then we go on towards writing actual properties. So as you can see here, I didn't emphasize this too much so far, but after the property and test macro, you can write a string containing the actual thing you want to test. So this is the perfect place to put your business rules. So here it says that the transaction will succeed. No, that it will update both accounts when it is completed. And the main interesting part is, because it's mostly the same as the ones before, is the account generator that we used before. Now here we can just use it directly and it will work as we expected. So we generate two accounts and we generate an amount, and the amount is always smaller than the account that wants to give money away. We do the actual transaction and we check that the values are updated, and that works. We also write a property for the other case when we don't have enough money. So only the values are different now. So the person giving the money has less than the amount we want to give, and we check that it always returns an error. Then we have a second example. It's about parallel map. So maybe first a little bit of backstory behind map for the people that don't use functional programming too much. It's basically a function that takes another function, and then it will apply the function to each of the elements inside the collection. So how do we write? No, wait, one step back. In this example, I want to show you how easy it is to define a parallel map in Elixir, and then check it by using the sequential map function you have from the standard library. So before we do that, we write a really small helper function at the bottom that just increments a number, just something that does work, so that we can then test our mapping function. The actual implementation of the parallel map is only 3 lines of code. It's really short because of the great standard library again. Basically what we do is we get a collection, a for each element of the collection, that's here we use the sequential version, enum.map, but we say for each element, spawn me a new process, and that's what the task.async does. So basically what you get is after the second line, it will spread out, have multiple processes computing one element, and then the second map says for each one of them, wait until you get result back, and that's how you make it parallel in an easy way. So we have our parallel implementation now, and now it's also really easy to write the property. We want to know if we apply the parallel version to an input, and the input is also new. We can generate random lists of integers, so random both in size as in the values that it contains. And for that list, we want to check if we apply the parallel map, does it give the same result as when we apply the sequential version? So yeah, it's really, Elixir is a really expressive language that you can write all that on a single slide. So what are good candidates for property-based testing? Pretty much anything that is related to business logic, but without side effects. That's really important, because you will be running it thousands and thousands of times, and most of the time side effects, like for example doing stuff with the database, is really slow. So keep that in mind, that you have to keep your business logic super fast. That being said, pure code in general is really easy to test with properties, because it's just, again, data in and data out. What are some patterns that we can test using property-based testing? So a lot of difficult words, but in essence they're really simple. So the first one is commutativity. That's when you can say A plus B equals B plus A. It doesn't have to be only integers. Right now for commutativity I don't have a good example, but for the next one, associativity, there I do have a good example. If you associativity is basically that you can move the parentheses around, and basically what that implies is that the order is not important. So with the parallel map you saw before, that would basically mean if the order is not important, you can just parallelize it, the parallel map, and then at the end you just reduce it, and it will be the same as when you do it sequentially. So yeah, it's a property I use really often to test in my code. Idempotency is also a really nice property. In the Elixir formatter, they have a property saying if we format the code 2 times, it should be the same as when we format it 1 time. Encoding and decoding should be a no-op. So that means, let's say for example you have a data structure, you encode it to JSON and then back. It should give you back a copy of the data structure you started with. The checking against the simplified model, we already did that before with the parallel map versus the sequential one. And business rules, they are also really easy to translate to properties. And there's also a ... Basically anything you can think of that you can say in terms of there's something of data going in, something of data going out, you can write a property for that. Sometimes I have this as a cheat sheet lying around when I write them. Then the final thing I wanted to say is so far we have been testing, how do we say it? The tests have all the state changes inside the test. And so with the bank example, we update some accounts, but we also check the updated state inside the test itself. But what if you have a more complex system? And so in the wild, in production, there are much more complex systems than I would be showing today. Is it also possible to write properties for those? Because often they involve, they have different behavior if you first do step 1, then step 2. it is possible, but it is out of scope for today because then I could fill another 30 minutes, I think. But if you are interested in ways of doing that, I would suggest looking at the Qvik Quick Check library or the PropCheck library. They are able to do that. And it's still a work in progress for Stream Data, the library I showed you today. But on the GitHub issue list, there is some talk of it being added to the library. So, as a conclusion, I think property-based testing is a really powerful tool for every developer. It does require more thinking up front, so it has to be valid for each and every input instead of just a few edge cases that you want to test. So that requires more thinking. It's also, well, I found that it's difficult compared to unit tests to write the tests up front. So what I often do is I write first 2 or 3 unit tests, then write the code I want to write. And then once that is working, I try to write a more general property that captures each one of those unit tests and extra. And once you are at that point, it's a really big payoff because now you can just keep on generating over and over new input values. But as with any tool, it has its limited use cases. So like I said before, if it's a really slow test, maybe you want to isolate that with a unit test and test mostly the slow part there. And then the pure logic, you could test that with a property-based test. And that's it. I have some few links. The first one is a link to the library I used today. The second one is Wikipedia link. It's really funny. Somebody made a script that scrapes GitHub, and it looks for repos ending in QuickCheck. So I've been talking about Elixir today, but if you use another language, I would suggest taking a look there, and hopefully your language is in there. And maybe you could start using it then there for your day job as well. And the last 2 links are from the company, the official website, and a technical blog. That's it. Are there questions? Yes?
Can you just you have the doc tests where you can write tests and the Elixir will look into it and see, oh, this is a test that you ready?
Yes.
Can you write properties in doc tests? Is that supported? Or?
It is supported. For Stream Data, it is supported. There's a few variants of the library, but the one I talked about today, it can do it. Maybe not with the property macro I showed you today, but I think you have to write the check all part inside the doc test, and then it will run the property tests along with the other doc tests. Yeah.
What I learned from Roy Osherov and Michael Ferris is that they state that unit tests should always have consistently return the same result, do not use random numbers and those kind of things. And those are used here in those generators.
Yes.
So I'm getting confused now.
You're feeling a little scared, I think.
Yeah, maybe. And also in those, when you generate those numbers, you also generate several test cases in the same equivalence petition. You have tested to reduce the test cases, and it seems that this method increases the test cases. So why would you use this?
Well,
all those test techniques are there to get all the amount of tests reduced, and by using test techniques to get up with at least amount of tests to calculate the product correctly.
Okay, maybe I emphasized it a little bit wrong, but or I didn't do it enough. But the property tests can be side by side with the unit tests. So you can have.
Yeah, that I understand. That I have no problem with, but I don't see the link that I've learned from with all the things that I just mentioned. Test techniques and this seem to contradict. The statement of the tools for returning consistently the same result and not using random numbers seem also to contradict with this technique.
Yeah. So what I. it's a good question. So what I would suggest doing is that first you have a few unit tests with important values or some initial tests just to make sure that the initial behavior is correct. And then the property-based tests can be used mainly to cover a big part of all the possible values. So that it has a different focus. Yeah?
One of the canonical examples for the property-based test, and I'm happy it wasn't mentioned here, is usually, for instance, string reverse. So if you're trying to reverse a string, you can, as a human, come up with maybe 10 examples. But for instance, did you contemplate Unicode? Did you contemplate different weird combinations of characters that are edge cases?
But the test techniques are there to uncover those.
Well, but if all the examples were generated by you in the unit tests, then you've only covered those. These techniques, the computer will generate the random things, and you can assert, well, if I reverse a string twice, is it still the same string? Because it should, right? But now I mentioned that given some Unicode thing, your implementation of reverse is wrong, and you would never have thought that scenario.
And what I like about these things are these, this list of, this community and this transform.
The relations between inputs and outputs.
Those kind of things that I like about this approach. But I'm not quite convinced.
What I also want to say is here we are making the inputs random and not the system we want to test. That's maybe also quite important to keep in mind.
On the same page, being random data, don't you encounter some flaky tests, some tests that sometimes work, sometimes don't work, sometimes work, sometimes don't work?
I'm sure you could make it deterministic by storing the seed from the random generator somewhere.
Yeah.
It will give you
It does give you back the seed if you run a mixed test, so you can rerun it with the same seed. Or you could write the unit test out explicitly afterwards. That's also possible.
it's just an extra check.
Yeah, but I think what my my helpful person in the crowd say is that as a developer we write some cases, but it's really hard to think of all the important values. Like I used to work as a C++ developer, and plus doesn't always add there. If you have the maximum number that can be stored inside the integer, and you do then +1, it goes back around, and that's something that would be found by property-based testing, but maybe not by unit testing. If you have infinite time, then unit testing is better, but property-based testing makes it easy to generate lots and lots of cases.
It can also help to identify your edge case scenarios, and it can also help you to write, if you identify this edge case scenario based on property-based testing, you can also write your unit test just to identify this edge case scenario and just document it in the unit test. It's still valid, I guess. It's just a helpful tool.
And I would make a comparison with the Chaos Monkey of Netflix. You have heard of that? It's like letting loose some AI just does random things and then breaks things, and then no one just came up with that until they let loose some random.
Yeah.
Awesome. I think we found a group that wants to discuss outside with a beer in their hand.